What is the average temperature of Tulsa, Oklahoma? Well, this is certainly a warm place in the country, as you can see by our forecast here in December. But if you take the entire year, the average high is 71 degrees. The average low is 50 degrees. So if you average those together, the true average temperature for Tulsa, Oklahoma is 60.8, which will round off to 61 degrees.
So I don't even know if a sensor or my weather instruments are working or not working. If they're not working, well, I'll give you a little bit of a basic idea. But here's a look at a temperature map. This is from December. So in the month of December, if you're talking about temperatures in 20s and 30s, it's cold. Your sensors, they're probably right. It's kind of a guessing game. So to quickly answer that question for you, it really is kind of figuring things out. So if you ever are in the middle of December and you see a temperature map that looks like this, where it's 100 degrees in Denver, it's in the 90s, something's not working, right? So you kind of have to use common sense, just like we have to use in all aspects of our lives. So if you see a weather instrument that says it's rained 15 inches of rain and it's sunny outside, that sensor's probably not working. If you ever see a temperature map that says this in the middle of December, probably not working, right? That's a pretty good way to give you an idea in terms of those temperature sensors. There's other ways you can check for it as well. The National Weather Service goes out and observes and takes a look at all their sensors, usually once every month or two, to make sure that they're working properly. So the Weather Service offices, wherever they are, we've got one here in Boulder, Colorado, one down in Pueblo as well, and also one in Grand Junction. They go out and take a look and make sure that the sensors are working properly. So there's a couple of different ways, but mostly it comes down to simple common sense.
All right, this is how do we predict the weather? How do you predict the weather? Well, that's a pretty good question. A lot of people don't exactly have a grasp on just how do we know this stuff. It really isn't magic. There's a bit of an art and a science to predicting the weather. One example of at least the science side of this is we take information from a radar, which of course comes not necessarily from our office, but from different weather offices across the country. We use different models. You see these lines right here? Those are called troughs. And this right here is a warm sector. Now, of course, in order to know what's what, you got to go to school for at least a little while to kind of know the logistics of that. But we use what's also called a weather model. In other words, we take different ideas about weather and we put them all into a computer. They get a bunch of different algorithms or mathematic equations that come out of that machine. And we take all of that information here, for example, at Weather Nation or even at your local station, kind of make our own decisions based off of past weather history and just general what we see outside of the window. So there's a little bit of everything that goes into predicting the weather. It's just a little bit of information that gives us a big picture forecast. Of course, people want to know how it is we get the forecast so far in advance. Sometimes we can get close to a 2-week forecast. The trick, though, is a lot of times that information isn't 100% reliable. So we have to rely on a little bit of common sense, for example, as well as all the information that we get from weather models. For example, well, this isn't exactly a model. Well, we're using a model here. You see our high pressure here, and there's our trough. So we take models, for example, but not just one or two. We take several, a lot of times in a row to try to get to a really good answer. This model that we're using here is the BAMS. It doesn't go out the 2 weeks that you might see a lot of times, but I would have to caution you, those 2-week forecasts, again, they're not nearly as reliable as perhaps a forecast like our BAMS, like B-A-M-S, it's just the way that it sounds, that give us something a little closer to the date. So a lot of times when you see our forecasts, we take models from way out and try to bring them closer to what we might expect today. I know it's a little complicated sometimes, but we also use numbers from today's highs, our climatology, which is of course a big word that means basically what happened in the past. A lot of times we can form our weather opinions based off of info from the past as well. Prime example here, like you saw, our high today in Kansas City was 59, or not too far from you into Dallas was 68, and our normal right there, that 59 in Dallas and that 42 degrees that you see there in Kansas City, well, what ends up happening is we take information from about 10 years ago, average all of those numbers, and get that norm that you see right there. That's what we call our norm or our average temperature. So a lot of times the information that we use from the past helps us form opinions for the future. And again, can't press enough that the closer it is to your date, that's how accurate your forecast is going to be. 2 weeks out, it's good to have at least some idea, but a lot of times that is definitely an educated guess.
How do we find out the chance of rain? Well, we use our instruments. A lot of what we use too has to do with radar imagery and satellite imagery. What we're looking at now, this is a radar picture of the state of Florida because we have precipitation there. I want to show you. We put this all into motion, about 4 hours worth, and it makes a movie to show us the movement, which is coming in from the south and southwest. Not moving very much at all, though, across the same areas we're getting rainfall. And so we know if it was raining here at point A, and it's all moving to the northeast, like you see in the image, that it's probably going to be raining at point B at some point too, fairly soon. We call this persistence in our forecast. You can look at it, you can say it's here now, but it's moving, and it's moving in this direction, so in an hour it'll be over here. Lake Okeechobee is where we're looking at currently in Port St. Lucie. There's been a lot of rain in South Florida, but that's how we know where it's going to rain and for how long. We use those satellite and radar images. What other instruments do we use for telling the weather? Well, these specifically, let me show you what we got. This one right here with the little cup on it, this is an anemometer. This gives us the wind speed, the little cups as they spin around. The wind hits them and causes it to spin, just like your speedometer on your bicycle. This is able to tell how fast it's spinning around. So we can tell wind speed, the anemometer, and the direction that the wind is blowing in because of this little thing. This is the wind vane. The thing by my cheek over here, this is a rain gauge. I don't know if you can see, but water falls into this. The rain does. And then it's calculated from here, goes down into the bottom, and it's calculated. So you know how much rain is falling in one particular spot. This is a thermometer. This tells us what the temperature is. Daily keeps up with the high and the low temperature reading for a particular day, for a particular spot. Also within here, we have a barometer. And that gives us the barometric pressure for this place. The air weighs something. It has weight to it. This can pick up that weight that's coming in from the atmosphere and pushing down on all of us in this device right here. Also has a hygrometer inside of it telling us about the relative humidity between the temperature and the dew point and what it would take to saturate the atmosphere. That's all contained within these weather instruments that you have. Anemometer, rain gauge, thermometer, hygrometer, all right here. Hope that helps.
So it's a big question. How do you know if a tornado is coming? Well, that's what we try and answer every single day as meteorologists. And the first big, overwhelming answer to that is if you ever see one, well, get into the lowest floor of wherever you are, or get inside, get away from a car, get away from the outside. You do not want to ever be outside looking at a tornado. Get inside as soon as you can. Get into the lowest floor, most interior room, away from any windows. Windows are bad with a tornado. So first things first, you see one, that's a good sign that you're getting a tornado. A couple other ways. One, you're ever watching the TV, we say there's a tornado warning, do what I just told you. Get inside, lowest floor, most interior room, away from any windows. And then if you ever hear about a tornado watch, which is different from a warning, a watch means that you might see a tornado that day. It means that conditions are favorable. Long story short, you might see a tornado that day, and that's one of those days, if you ever have a tornado watch and you're living in a place that has a tornado watch, that you need to be kind of ready to go and be ready to see some possible tornadoes. And of course, if you ever see one, get inside as soon as you can.
And our next question is, how do you change and move the giant map I see behind you? Well, it's all with this clicker that we hold in our hands. You have to make sure that you have this before you go on the air, because if not, you have to run off and try to get one of them, because otherwise these maps are not going to change. It's much like a PowerPoint presentation. So if any of you have ever used PowerPoint, it's similar to that. You just have to press a button on the clicker and then it makes the map move. It just tells the computer that's over there, you can't see it, but it's off the screen. It tells the computer to move the maps. So I'll show you. As I click, it'll move from the national map now to the next map and then to another one. So you just click as you're up here and then it will advance. It's a little challenging though, because As you might have already been talking about, we don't use scripts when we're up here. We're not reading off of a teleprompter. You just have to kind of make it up as you go. So you would look at the temperatures that you're seeing, 63 in Atlanta, 58 for St. Louis, 65 for Wichita. And when you're done talking about this map, then in my left hand, I'm clicking with the clicker, and then it moves on to the next forecast, like for Denver, Colorado. And then I move through this one, click one more time, on to Chicago, so on and so on. So the meteorologist is in charge of how fast all the graphics get moved throughout his or her show. Okay, this question I love. It is, how does it, meaning the map, work? Well, as you're looking behind me, you think that you're seeing this gigantic TV screen, or conglomeration perhaps of TV screens, that is showing you this image. Well, looks can be deceiving in TV. I will show you, because as I start to move over and get a little closer to this edge, normally I'd be pointing at Denver. If I go a little too far, however, did you see what happened? Did you catch it? I'll do it again. All right, watch my hand. Oh, and then the rest of me, goodbye. This is what happens because I'm actually on a green screen. This doesn't really exist behind me except for inside the computer. And that's what it looks like when we're here in the studio. This entire image that you're seeing behind me is virtual. And the green here, that is actually what I am seeing. So if you're looking behind yourself here, standing in front of the green screen, how then do you know where to point, right? Because, well, where in the world would you be pointing if there's nothing really there? Well, let me show you what's happening on this side. There's another monitor back here, but we'll just show you this one. That is what's actually there in the studio, is this monitor. And I can walk over and show it to you. So there's this monitor right here. I see myself in it, and I see myself in front of the image. So this big national map that's behind me, I'm actually looking at it on this smaller TV, and I see myself pointing to different things in that TV. And that's how I can be able to tell where to look. There's another monitor like that just on the other side. It's just we can't widen the camera out enough to be able to show it to you. But normally, since I'm right-handed, I'd be looking over at this side, and I can see myself in that small monitor, just like the one over my shoulder, so I can see St. Louis, pointing at 58 degrees there. Omaha, 58. Wichita, 65. Dallas at 70. And that's what I'm doing here. I'm not actually pointing to specific places that are behind me because this is actually what I see, a green screen. That's all that's there. But what you're seeing at home is the mixture of the two. And if I turn around and use my left hand, then I'm using that monitor to look at. Right now it's all green. If we put the map back, then I can see the numbers. 61 in Charlotte, 55 for DC, New York at 51 degrees, and then I reach way up here, Boston at 46. Pretty cool, huh? Same technology that is used in a lot of your favorite movies, especially if you happen to know Harry Potter, favorite of mine, how he has an invisibility cloak. How that works is that he's wearing a green sheet, and he's filmed against a green backdrop so that it makes him disappear. Another cool thing about this is that this is why you'll never see any meteorologists wearing green, at least if they work in front of a green screen, because if you wear green, what do you think happens? Yeah, you're right. Guess what? You disappear in front of this green screen because the computer says anything that's green is going to get replaced with this big image. So no green ties, no green suits, no green shirts. If we did that, we would just blend into the graphics. Pretty cool, huh?
You know, a lot of people want to know just how hard it is to forecast. I wouldn't say it's completely difficult, but the job itself often comes with a lot of different challenges. For example, getting the 7-day like this correct. Sometimes there are a few hard things that come along with it, like is there a cold front around? Are we going to have a lot of warm air come in? So I'd have to say is forecasting difficult? Not necessarily. I mean, are there challenges? Of course there are. In particular, where you guys are, Ice can be a definite problem around this time of year. So getting an ice forecast or even a snow forecast can be a little hard. I mean, there are different elements that'll come into play. For example, how much moisture are we going to have at the surface, like right there on the ground? Is it going to be below freezing? A lot of questions a lot of times don't get answered until they actually happen. So again, there are some challenges, but I'd have to say overall it's a great job to have, and you kind of live and learn in this industry. You learn patterns, for example. We've seen perhaps the seasons change, what happens this time of year typically. So a lot of times we have to go, again, I've said this 100 times, but you have to go back in the future to get a good or back in the past to get a good idea of what to expect in the future. But overall, I wouldn't say my job is particularly difficult all of the time, but I would say it is fun 100% of the time.